So our final learning objective for Unit 2 is average rate of change applications. And applications is just a mathy way of saying they're going to be word problems. All right, so from performing word problems that use average rate of change, there are a couple things you want to remember. So I don't think I listed here, but one thing to remember is that average rate of change and slope are very closely related. And we're doing slope and average rate of change. The input, the x value should be on the bottom of your fraction, the denominator. And the output, the y values, should be in the numerator of your fraction. So when you're doing these word problems, you're gonna have to identify what's input and output, so you put it in the correct place of your fraction, your average rate of change calculation. Right. And just kind of one general fact is time. If time's in one of these problems that I'm giving you, it's almost always gonna be the input, because if you put in one time, there's only one possible output you can get. All right, so time is very often the input for these average rate of change problems. All right, so here's our first example. The population of Foxcroft increased from 100 students to 140 students from 1990 to 2010. I find the average change in students over that time period. All right, so just again, as a reference, time, so anything related to time like years is going to be our input. All right, so our average rate of change formula. All right, it's going to have the input on the bottom. All right, so we're going to put our second time period first, minus our first time period. That's like the x2 minus x1 in the slope formula. And then I'm going to put their corresponding outputs. Well, in 2010, there was 140 students. That's going to go above 2010. In 1990, there was 100 students. That's going to go above 1990. All right, so again, just identifying what the inputs and output are, and then making sure you pair them up correctly. All right, so time is on the bottom, population is on the top. All right, then I can simplify. 140 minus 100 is 40. And 2010 minus 1990 is 20. And that is 2. All right, and here, now that we're actually talking about a real world problem, we can actually put units on this as well. So what is the average rate of change? It's 2. The top unit was students, so there's 2 students. And our bottom was years. I guess that's what year was. So our average rate of change is 2 students per year. So on average from 1990 to 2010, 2 new students came to Foxcroft. All right, so maybe in 1991 there was 102 students, 92, 104 students, and so on. All right, so that's the average change of the population over that time period. Of course, that's probably not the exact number. It probably went from like 100 to 103, then maybe next year is 102, and then like up to 110 or something like that. All right, so it's not going to be exactly 2 students a year, but on average, it just slowly crept up at 2 students per year to get to 140 at that time. All right, the price of Tesla stock changed from 800 to 650 over the last 2 years. Find the average change in price per month over that time period. All right, so they want to know the average change in price per month. So there's a couple hints. Per in word problems is just a word that's going to mean division. So this is going to be, price is going to be on the top of a fraction, and months is going to be on the bottom. So that kind of helps us as well. If they're asking for a price per month, we automatically know what goes on the top of our fraction and what goes on the bottom. So we know when we're doing these average rate of change, the difference in the outputs goes on the top. So we're going to take 650 and subtract 800. And this one doesn't give us 2 different time periods, but they do tell us it's over 2 years. So they're not telling us where it kind of starts and where it ends, but we know it started 2 years ago and it's ending now. But I don't want to put a 2 on the bottom because that unit is years. The unit they want is months. So I have to convert years to months. So instead of 2 on the bottom, it should be 24. All right, so just keep kind of small things like that, especially if they're asking for a specific unit. All right, make sure your units match up to what they want. All right, so 650 minus 800 is negative 150 over 24. And for word problems, generally we actually want to type it in a calculator so we get a answer that makes sense. So we get negative 6.25. Price is dollars per month. All right, so on average, over the last 2 years, Tesla stock would have dropped, right? Negative means it's going down. It went down by $6.25 every month. All right, so that's the kind of calculation you can do when they just give you the amount of time. They don't kind of give you the starting point. It actually just kind of tells you what to put on the bottom there. All right, so here's one for you to try on your own about these wolves being released into a national park. All right, here's the answer I got. All right, you had 60 wolves at the end and 40 wolves at the beginning, so that's a difference of 20 wolves over 10 years. If there's 20 new wolves over 10 years, that gives you 2 wolves per year on average. Again, maybe not. Maybe one year there was 3 and another year there was 1 or something like that. All right, but on average, there's 2 wolves per year. All right, and the last thing we'll do with these average rate of change calculations is help predict the future. So we can use old information to figure out how things are changing on average. We can say, well, if that trend keeps going, so maybe we know between 1990 and 2000, this is how something was changing. Well, in 2030, we're going to expect that change to keep happening, and we'll be able to figure out what's happening in the year 2030 or something like that. So we can use the previous information about the past to help predict the future. All right, so the price of college went from $40,000 to $80,000. Again, these are completely made up numbers. I just made up for the problem. I have no idea if these are right. Over the last 30 years. All right, if this trend continues, how much will college cost in 20 years? First, we need to figure out how much is this changing every year. All right, well, there is a difference of $40,000 in the price of college over the last 30 years, which is, I'm going to have to round a bit, but let's see, 40,000 divided by 30. All right, so it's an increase of about $1,300 per year, and again, that's dollars per year, over the last 30 years. And now we know if this trend continues, how much will college cost in 20 years? Well, we have 20 extra years, so 20 more years of it changing by that amount every year. So in 20 years, the increase is going to be, let me multiply these things, 1, 2. Increase is going to be $26,666.6. But it already costs $80,000. So that the increase, we add that to 80,000. And in 20 years, if this trend continues, college would cost $106,666.60. And there was some rounding in there, so it might be a little bit different. But all right, this is what we mean by using a previous trend to predict the future. And then now that we know the kind of trend that's happening, we can figure out when will college cost $150,000 per year. All right, so this might require, because we're solving for when the dollar amount is going to be, and that's what the equal is to, we might have to make an equation. So we're figuring out $150,000 is equal to, what type of equation can we solve? Well, we know for every year that we go, we have an extra $133.3, right? All right, so if I'm trying to figure out how many years are going to pass, I need a variable x. But if I just had this equation, that's figure out when the increase would be $150,000. But we know right now college costs $80,000. All right, so this is the equation. College currently costs $80,000. It's increasing by the slope, the average rate of change, that amount, and I actually forgot a 3. And I can use this to figure out when college is going to cost $150,000. So first thing is subtract. I'm going to get 70,000. Oops. So I know this is going to occur. College is going to cost $150,000 when the increase is $70,000, and that increase is going to happen. Oops. I'm taking 70,000, dividing it by 1333.33, when I get to 52.5. All right, so in 52 and a half years, college would cost $150,000 per year. All right, so go ahead and try this one on your own. All right, the population of Middleburg grew in the last 20 years. All right, how many more people will live here in 5 years. And here's the solution I came up with. The first thing I want to figure out is how much are we changing on average over those last 20 years. So we have 1,500 new people, right? That's the difference in those two numbers. In 20 years, well, if we have 1,500 people in 20 years, that means we're averaging 75 people for every single year. All right, and if we have 75 people every year for 5 years, we just multiply those two numbers together to see we're going to have 375 new people after 5 years. We have 375 new people. We currently have 7,500 people, so we add those two together to get 7,875 people in Middleburg in 5 years. Again, that's assuming that this average trend were to continue. All right, so these word problems, all right, it's all about finding the average rate and using that together to help you figure out the information that you care about. All right, so go ahead and practice. All right, the main thing the skill check's gonna be testing is finding the average rate of change of some situation. All right, so you won't have to predict the future on the skill check, all right, but that's on the practice too. It's a good thing to practice because it kind of really shows you understand average rate of change and how that's related to the different things that are going on. All right, but go ahead and practice these word problems, take the skill check. All right, this is the last learning objective. When you're done with this, you can move on to the projects.